aerial velocity. Let a particle is moving in a plane curve, then rate of change of sectorial area gives the aerial velocity. This is sectorial area. That particle is moving from P1 to P2 in time t and P3 to P4 in the same time t. Then we have one result that the sectorial area A1 is equal to sectorial area A2. Let's prove this result. So next result is prove that aerial velocity is constant and also prove that linear velocity v is directly proportional to small p, that is perpendicular from center to the tangent. Now let p be the position of particle at any time t with r and theta, and q is position of same particle after time delta t with r plus delta r and theta plus delta theta. Here particle is going from p to q in time delta t. So this is the sectorial area covered by particle in time delta t. What is formula for this sectorial area? Here q is very near to p. Say q is here. So we can consider area of that sector is equal to area of triangle POQ. We have to consider this result here. So to find area of sector, we will find area of triangle. Area of triangle is half into OP OQ into sine of middle angle, that is sine theta delta theta. Now what is rate of change of sectorial area? Area divided by delta t and then limit delta t goes to 0. So here sine delta theta is going to delta theta under limit. Now we will neglect the second term delta r into delta theta. Why? Because delta is very small and we have to neglect its higher powers. So we will consider only first term r into r square delta theta by delta t. And under limit delta always becomes d. So we have rate of change of sectorial area half of r square d theta by dt. And we discussed in first video this result is equal to h by 2. So rate of change of sectorial area, that is aerial velocity, is h by 2, which is constant. So we prove the first result here. Now for second result, we'll again find sectorial area from another formula, which is half of base into height. So here, what is base? If q is very near to p, say at this point, then we can see this base pq. This base pq is along tangent. So perpendicular is p. Half of pq into p. PQ is delta S here, arc length. So area is this one. Now what is aerial velocity? Aerial velocity is rate of change of this area. So to find aerial velocity, we divided this area with delta t. Now under limit again, delta will become d, and ds by dt we know is equal to v. So this is aerial velocity, equation number 2, and this one is also aerial velocity, equation number 1. Comparing both, we have v is equal to h by p, that is v is directly proportional to 1 by p or v is inversely proportional to p. P means length of perpendicular from O to the tangent. So second result is also proved. Now some problems for you. That a particle is moving along a plane curve under a central force with a focus as the center of force. Center of force may also be center point, but here center of force is at focus. So problems are to find law of force, velocity of particle at any point of its path and periodic time for different curves, for ellipse, for hyperbola and for a parabola. Uh, Practice these results.